I'll wait for the banner to show up before I start talking. There we go. So hello everyone. Welcome to, oh wait, what number is this? 43. It's at the top of the banner. That's right. It was 42. Keep your towels handy last time. So the way we normally do this for folks who may or may not have been with us before is feel free to submit questions. You can dump them in the chat. You can unmute yourself and say hello and ask your question there. And start doing that whenever you're ready. Then we try and get through the questions. Usually we get a few and we end up talking about stuff. There were some questions that came in earlier on Twitter. Hopefully some of those folks are around. Also, friends on Twitter were who pointed out that we had let the the regular team meeting slide off the calendar. So apologies for that, and thanks for letting us know. I think Wit probably also let us know on Yammer. So thanks for the prodding. And sorry for the delay. We also have Charles with us this week from the ESF team, who came around to answer some questions on Fabric Observer and all the stuff that we're doing there. If we don't have any questions off the top, I can just let him ramble for a little bit about the stuff that he's been working on, because I think it's pretty exciting. And I know some folks were interested in it, so maybe if they weren't able to attend, then at least we'll have it recorded for them. And I didn't really check with Charles before telling him I'd put him on the spot like this, so hopefully that's okay. So you can either save him by asking questions, or we're going to turn it over to Charles to talk about all the work going on with Fabric Observer. All right, Charles, I threw you under the bus. What do you got, buddy?
Oh, man. Thanks a lot.
So tell us a little bit about Fabric Observer, first of all, for those who might not have heard of it.
Sure. So Fabric Observer is essentially a highly configurable, kind of user-centric watchdog service, if you will. We call them observers because essentially each watchdog, all it does is what you'd expect a watchdog to do. You tell it to watch specific things, and it does. And if some threshold is reached, it'll emit a Service Fabric health event, either a warning or an error. And this stuff will also, shoot off to whatever telemetry backend you've set up. It already implements, some of the major Azure telemetry systems. So, for example, App Insights and Log Analytics, and of course, Event Source, which you can use if you want to pump it to something like Kusto or whatever. And so it's basically designed to enable a user to say, I should step back for one second, because some people may be confused that we also release something called the Service Fabric Monitor Service, right? And what that does is essentially we'll look at the aggregated cluster health and emit information, but it's a different sort of concept, right? The concept here is, as a Service Fabric developer, Fabric Observer gives you full control over, I'm only interested in learning how much, if my service, so let me give you an example. Let's say you have a Fabric Observer, a Service Fabric application of a certain type, and it has n number of services bound to that type, right? So an application type is essentially some abstract concept of a container of a number of services related to single type, right? So we're talking about types here and instances. So in this case, you're like, hey, for my type foo, if any of the services of this type start using more than 20% of total CPU time, so all of the cores, total CPU time, I want to emit a warning, right? I don't want you just to kill my process, like something that would happen with, if you think about like resource governance. What I want you to do is to let me know. I will be able to then send that information to some, let's say Log Analytics or App Insights, and then I'll generate alerts based on that. I'll get an email or whatever, or I'll fire off some mitigation that I've written. And so the idea is to give you lots of control over really understanding like, how much disk space is available, right? So we run into a number of incidents on the Service Fabric team where we'll spend 2 or 3 hours trying to diagnose like what's going on, why did this fail? What's happening? And then it's like, oh, there's no disk space. And so if there's no disk space, things like Windows can't work very well. And if things like Windows can't work very well, then nothing that runs on Windows can work very well, like Service Fabric. And so we can't write logs, we can't do this, we can't do that. Strange things start happening. And then we'll go, oh, it was just a disk space issue. And so with something like Disk Observer, you could say, hey, for any of the disks in my system, in my deployment, if they hit 80% capacity, fire off a warning, right? So you'll have that information. It'll be in the event store. It'll show up in your telemetry backend. And you'll be able to do interesting things and really get a sense of like how is my system actually working in terms of resource use. Another common issue we see is port abuse. So you'll just start eating through all of the Windows dynamic port range or ephemeral ports, and then like networking won't work anymore. Right? You're like, I can't access this, or for some reason this service can't communicate with this service, and blah blah blah. And then we'll go in and go, okay, let's see what could be going on here. Oh yeah, so there's no ephemeral ports left on the system. So that's not good for Windows. That's not good for Service Fabric. And so really the idea is to present you with a very simple way to sort of configure um, your warning and alerting system at the source level where these events are emitted in the first place, but you have full control over what you care about, right? So
So if I will interrupt you for a second to say, yeah, I mean, what if I have some other random downstream dependency that I care about, or some dependency on the box that I want to make sure is there, or I want to be able to poke my application and make sure that I'm meeting my own SLAs on my own APIs. Is that something that the Fabric Observer can help me with?
I mean, what are the side effects? So in other words, like what would I monitor in that case? So are those services reachable, for
Mhm.
example?
Right.
Yeah, so Network Observer is an interesting observer because it essentially will try to make sure that some endpoint or even a local service is available, right? Meaning that it gets a response, it gets some header back. It doesn't matter if the authentication didn't work, if you have a complex authentication system, that's not the point of Network Observer. Can that endpoint, is it reachable? So if you get a header back from some service, from some server, it means you reach the server. It doesn't matter if it's saying, I can't authenticate you. That's a different sort of issue. So all Network Observer cares about is, can I access this endpoint?
Mhm.
Is this thing I'm interested in reachable? Um,
What are some of
it-
the like extensions that Fabric Observer gives me? Can I write my own types of observers?
Absolutely. So great question. So Fabric Observer is written in C Sharp. The code style is designed to be highly readable, as in sort of not super abstract. There's like maybe 3 interfaces, 4 interfaces. There's one base abstract base class that you have to implement. So an observer is a type, it's a class. It implements observer base. Observer base is an abstract base class that has a ton of functionality already built in. Thus, it's abstract. So it has concrete and it has purely abstract. The purely abstract members you have to implement are like run async and report async, right? So run async basically is where you're going to put all of your code for what the observer does. Observe async will work with the system to sort of orchestrate emitting the results, right? Or whether or not, so for example, the base class has this function that takes, um, a type, if it's numeric data anyway. The fabric resource usage data is a custom type. So you'll fill up instances of that with whatever you're monitoring in terms of it's numeric or not. Generally numeric, yes. So in other words, rather than going too far down this rabbit hole, you can look at the source code, aks.ms whack fabric observer. Um, it's an open source project. It's written fully in the open. So you'll see there's a develop branch and then there's the master branch. Right now it's at 2.0.5. And so it's definitely ready to be used. One of the things that it doesn't afford users is the ability to change parameters at deployment time, right? So the way it exists today, you're going to have to either clone the project or you can just download the SFPKG, which contains Microsoft sign binaries. Open that up and adjust the configurations based on the pretty extensive documentation that's on the GitHub repo. I would go to the Getting Started Quickly section, which has scenario-based examples that can show you how to what the configuration actually looks like. So basically, there's two choices. There's two types. There's the typical settings.xml stuff, and then for the more complex um, configuration, which would be like App Observer, where you have like multiple app services that you want to watch, rather than doing that in XML, which would be incredibly ugly. It's JSON, so it's really easy to read. And so you'd go in there, adjust those. There's already samples there for you to see how you could do it. And there's also a lot of documentation. Out of the box, if you were just to throw it up on your cluster without doing anything, you still would get the advantage of Disk Observer would start emitting warnings when it hits 80%. Node Observer would start shooting warnings when you're eating 80% CPU, 80% memory, that type of stuff, which is also, kind of useful.
Yeah, useful.
Because we see a lot of sort of memory issues and resource use issues. This is actually, just so if customers out there know this, there's actually teams in Microsoft that are running this in production environments. And we ourselves use it in one of our production environments. And I highly recommend. So the key is to know that you do need monitoring in your Service Fabric clusters, right? So the first thing is to understand there's a need for you to understand how your services are behaving at any given time, because there may be things that you didn't expect. But the final thing I'll say here that's really important is thresholds only make sense after you've done testing, right? So if your service under load never eats 30% of all available CPU on the virtual machine it's running on, then you would know that a meaningful threshold would be, yeah, if I hit 35%, I want a warning, because I never do that, right? I have data to show this shouldn't happen. And then that gives you time to come back and go, okay, let's try to dig into this problem before it turns into an incident. That's particularly important with memory and say like highly reliable, stateful applications that you write. Sometimes you'll see that all of a sudden, like you're just eating through all the memory, but it could be actually most likely be a user code bug. But you'd like to have the chance to mitigate before creating an incident if you have enough time in terms of the threshold that you've created to start doing a quick investigation. And also there's mitigations where you could just restart the code package, for example. It's a simple mitigation that'll definitely solve port abuse problems. But
Yeah.
like I said, I would highly recommend checking it out. It has a lot of levers and easy to use and easy to configure, but at the end of the day, highly useful. And I recommend you put it into your cluster. The last thing I'll say is it's a managed application that I worked hard at ensuring it itself doesn't eat a bunch of memory and eat a bunch of CPU. So you'll notice the working set is pretty small, and most of that working set is actually the .NET runtime. So it also affords some pretty advanced statistical stuff that you can play around with if you're interested in like sliding window, stuff like that, circular buffer, depending upon how long you want to, like you said, node observer, you want it to like view for a longer amount of time, but you're only interested in the most recent amount of data. The other type of kind of, um, you know, default data type is a list of whatever, like that will just be held in memory. These are small and they don't need a lot of memory. So blah, blah, blah. If you have any questions, please ask. But like I say, please go to aka.ms/Fabric Observer, check it out, clone it, play around with it on your local dev machine. Works great there as well.
Great stuff, Charles. Thanks for talking about it.
No
And if
problem.
folks have
Thanks
any
for having me.
questions, feel free
I
to.
just have a couple of questions on the Fabric Observer, if you guys don't mind.
Yeah, sure.
So yeah, the first question is it recommended to have one observer per service, or do we have one master instance for all the services inside an app instance? That's the first question.
So, so that's a good question. So I neglected to mention that Fabric Observer is a -1 singleton stateless service. It runs on all your nodes. An observer is just an instance of a class. So for example, App Observer running on one of your nodes, you definitely want to have it watch all of the services that you're interested on that node, right? If I understand your question correctly. So the EXE, the service itself, it contains a bunch of instances of observers that you've enabled. So I say bunch. So today there's, I think, 7 observers. One of them is by default not enabled because it's more of an advanced scenario. And, we don't necessarily want you as the user watching the behavior of the Fabric system services, right? Because there's not really much you're going to be able to do if one of our services starts acting weird, right?
Right.
And we don't know what weird actually means. So focus on your services, which is the whole point. Fabric System Observer is what I'm talking about. That was written because it was actually an interesting problem, and rather than just having it be there and then removing it, I just disable it by default. Feel free to use it, but there's caveats and understand. And also by design, Fabric Observer runs as network user, right? You don't have to run a service as admin for anytime you create one. So like others, so if it's because it's a network observer, something like Fabric System Observer can't monitor any of the system services that run as system, right? Because it's a lower sort of security level. And so you can't have a network user process query the system for a process running as a system process because it's inaccessible information. And so that's stuff to keep in mind. But to answer your question, if you look at the way appobserver.config.json, which lives in the config folder, that'll show you an example of multiple apps, multiple ways to specify what you want to watch as JSON object elements, right? So it's an array of JSON objects.
Okay, so does it use some kind of internal, so how does it know what services are hosted? Does it contact the gateway service or something to ping all the available services to start observing, or do we have to specify all the services in a JSON file and then initialize that?
Yeah, so if you simply wanted to watch, yeah, I mean, basically you can't ask it to just watch any service that's running on the system. You have to specify either an application type name or the app URI name, right? So app name is a URI, but it's a string in the JSON. And there's also things that you can say for app type foo, I want to watch all services but these, or I only want to watch these. And those are the service include list and service exclude list JSON configuration properties.
Got it.
So what it does internally is it obviously Fabric Observer is 100% open source. It only uses public APIs. So it queries the system. It asks the runtime, please give me, all of the apps that are of this type, or get me the information about the app named this because you provided that. So if you look at the implementation of App Observer, that's where in that logic, it goes and says, oh, okay, I have this JSON stuff. I've parsed through it all. And now I'm going to iterate through everything in there and ask the system every time I run, because there could be a case where I was observing an app that's no longer there, right? So it doesn't cache aggressively. Every time it runs, it goes and creates the list again to make sure that the app's still deployed, and it'll continue its observation of a number of resource usage for that process. So for an app name, Fabric My App, and then of course that maps to the service process that's running on that node. It doesn't matter if it's hosted, if it's exclusive or not. But not to get into that rabbit hole right now. The point is, it will tell you how many ephemeral ports your service process is using, for example. How much memory, more memory meaning working set, right?
Yeah.
And then how much CPU time total, stuff like that. It did used to have more complex stuff like, disk I/O and stuff, but that started getting a little bit complicated. But you will note that Disk Observer has a new feature where it will monitor queue time, how many disk operations are in a queue, which is an interesting and useful thing to know. And you'll see what the default value for that is. You can feel free to move that up and down, but that's typically a good number.
Mm-hmm.
And sometimes you'll see Disk Observer warn on, this queue time is too high. There's just too long, like, 12 or 24 or whatever. But take a look at that.
Okay. My second question I've already asked about containers. I think Matt Snyder can answer that.
Yeah, we'll get there
at the end of the call. And my last question for today. So does it integrate well with on-prem log providers, or is it only for hosting on Azure that your Fabric Observer works?
So that's a great question. Now, if I understand you correctly, so the way that the implementation works is that the provider is up to you. In other words, you have to implement an interface.
Right.
That's it.
But I can pipe the logs to wherever I want, right? I mean,
you can pipe, but you have to write that code.
Got it. Okay. Thank you.
You're welcome. Thank you for asking questions.
Yep.
Yeah. All right, we got some questions in the chat as well. Thanks everyone for your questions, and keep dumping more in the chat or jumping in. We'll start to run through these. So Oliver asked about ephemeral OS disk support, how it stacks up a temporary disk for performance, and might this be the default configuration in the future? So just to be clear, there's really two disks always in an Azure VM by default. There's the OS disk, which traditionally is backed by blob storage. So when you write to the C drive, it's actually going and getting backed into blob. And then there was the temp disk, which was usually a view of a local disk. It was physically attached storage in the VM. And what the new ephemeral OS disk support feature in Azure is they're making it so that the local OS, the OS disk is actually also local. And that provides a bunch of speed and performance benefits, basically. This is actually something that existed previously in cloud services that is now lighting up in VM scale sets as well. We announced support for it. There wasn't really a lot of additional work that we had to do because it's just ensuring that there's nothing special when we turn on the feature. It's really a feature that comes from VM scale sets. We just wanted to make sure that we didn't find anything strange when people started to use it. So there wasn't really a lot of additional work on the SF side. Regarding whether it's going to become the default or not, it kind of depends. While there are performance improvements, there are some reliability differences. So in one sense, it's quote unquote more reliable because if storage ever has any issue, then your OS doesn't have problems now because it's not trying to talk to storage. On the other hand, anything you write to that OS disk gets lost if the VM dies because it's not backed by storage. So there are some trade-offs. I don't know which way we'll end up coming down in terms of default, but we do think that there are some interesting performance gains for workloads that care. And, they're really kind of like what you would see if you were using the temp disk for state or operations today. So we think about it in those two ways. And it's just good to know that, it's another feature that came up through VM scale sets that we're glad to see and that people can now take advantage of with confidence. If there's other questions about it, Oliver, just let me know. Stephen asked about container support and Service Fabric. Service Fabric has supported, for example, Windows containers since they were first announced. I don't even know how long ago that was now, a couple of years, I guess, at least. And so we have a long history of doing work and integrating with Windows containers there. So for example, though they're fixing a lot of this now, historically Windows containers, images were bound effectively to an OS host of the same kind and or same version that they were built against. And that raised all sorts of difficulties. So SF has features where you can say, hey, if the host OS, is this version, use this container image, otherwise use this container image for the same service. Of course, the other things that you get from running containers in SF are the same things you get from SF generally, which is that we have a lot of integration overall. So custom metrics are supported out of the box, service discovery is supported out of the box, DNS naming is supported out of the box, and you get this sort of failover and management, rolling upgrades, health, all these things that SF does for quote unquote regular services, we do for containers as well. And so we see a lot of value that people get out of being able to manage maybe their stateful services, their stateless services, and their containerized workloads all in one environment, right? Your deployment pipeline looks the same. Your upgrade calls look the same. A lot of your monitoring looks the same. Clearly, there are going to be some differences because a container runtime and containers are a different artifact than, say, a process or something using the Service Fabric SDK. But being able to mix them all together and really choose which type of hosting is good for you is a big benefit that we see. And that's something that no other orchestrator does. Most other orchestrators, maybe with the exception of Mesos, kind of only support containers, right? If you pick containers, then it just does containers. And so if you had some random exe that you wanted to launch alongside your container, you would have to containerize it first. Or they don't support, workloads with SDKs. There's no SDK to really program against. You just have the container as a box. And so those sorts of things and that integration are really where we see Service Fabric differentiated between other orchestrators. There's also things that Service Fabric does around HA that a lot of other orchestrators don't do. Like we care deeply about fault domains and upgrade domains. We have a lot of integration with Azure in terms of Azure maintenance and ensuring that even your own infrastructure operations don't accidentally clobber a workload. And we see those being differentiated things that we're going to continue to grow and evolve. So we think of containers as just another type of workload that you can host inside of Service Fabric. It plugs into the existing kind of service model that we already have. And it's another tool out there that people can use where appropriate. Like if you have, some Windows workload, or if you have Service Fabric on Linux, some Linux container workload, and you want to run it side by side with some other processes or some other microservices that you already have, that's an option that's available to you, and you can mix and match things as they're most appropriate. If you have questions about other, very specific features, feel free to ask, or we can maybe have a conversation offline if you're wondering how, cluster resource optimization is different between Service Fabric and Kubernetes generally, for example, or between SF and Mesos. Those are interesting conversations, but they're very, very deep and technical and got a lot of details to them, which we're happy to help with. It just is it's a white paper. And so we can we can have that conversation offline or separately. I want to get to some of these other questions if that's okay. But it's a good question. Yeah, we've been doing containers for a while. It's just that people are finally starting to notice, which is good.
So should we go to the next question, Matt?
Yeah.
Prakash, right? Prakash. Hey, Prakash.
Hey, how are you?
Good. How are you?
Good.
So the question is, we have a bunch of stateful, stateless active services. And if you need to orchestrate these pre-existing services as container images on Service Fabric, what are the exact steps we need to follow? How can we marry Docker plus Service Fabric seamlessly? Visual Studio tooling for local deployment and Azure DevOps templates, PowerShell commands for CI/CD would be ideal. We do have documentation and samples around this, right, Matt? If I'm not correct, we talk about how to.
There are ways to containerize your existing services, but we would also typically ask, what, do they need to be containers? And if they're containers, typically we see containers as more agnostic. They don't use the SF SDK, though we have support for it. You can containerize a service that uses the Service Fabric APIs. Most of the time, though, when we see people containerizing things, it's either to get a security benefit where you want to run in Hyper-V, or it's to deal with resource governance. You want to put some resource limits on the service so that they don't, leak and consume all the resources. Service Fabric supports the resource governance out of the box already for services. So you shouldn't need to containerize just to get resource governance. And if you containerize something that uses the Service Fabric SDK, then you're still bound to the Service Fabric runtime. So you don't get some of the portability benefits that containers, when people think about containers, they think about containers bringing. I don't know that there's tooling specifically to convert an existing Service Fabric service into a container, but there are instructions online for how to do it. There's a doc specifically about containerizing your Service Fabric services. Regarding VS tooling, I know that the VS tooling has been improving in general for kind of our traditional F5 experience. I know that there were also some differences and hangups with, like, depending on what edition of Windows you had, like if you had Windows Home Edition versus Pro versus Server, and what you were developing on, then certain different experiences were different. If you're still having issues with sort of the local development cycle, I'd say let us know, follow up, and we can get you in touch with the tools team who's working on those scenarios and see what the issue is or what's tripping you up. But yeah, in short, you can containerize existing services. Most of the time we don't see people do that. We see containers used for separate workloads that already were containerized in a lot of cases. And then we see containers used for both security isolation and resource isolation, though usually the resource isolation, if you already have existing SF services, you can just use the existing resource governance capabilities to tackle that. You don't need to take on containerization necessarily.
So if I were to containerize my stateful service, let's say on a Windows container, I cannot lift and shift that same exact image and run it on Linux. Is that a supported scenario, or is it not?
You could do it on Linux if that is also a Linux Service Fabric cluster, but you could do that anyway with the .NET Core process.
Got it.
So you couldn't pick it up and run it on Kubernetes because it has a dependency on the SF runtime.
Right.
So it depends on what you're trying to get out of containerization is more about what we would recommend rather than can you or can't you. You absolutely can, but the question is, what are you trying to gain by
Correct.
it?
Yeah. So I would personally, leaning towards process orchestration, because that gives us the best density, right? I mean, in terms of memory usage and all that. But that anytime we talk about orchestration, if you don't say containers 3 times, then you're a loser. At least in the current environment, right?
Right.
So that's why I asked that question. Thank you. Thank you so much.
Yeah. I hope that explains it, right? We tend to be very pragmatic about, again, this is the thing, because Service Fabric can orchestrate things that use the SDK, bare processes, and containers, we get to be very pragmatic about asking, do you actually need the containerization part? If you do, it's there for you. But in a lot of cases, we see people picking up containers to get, say, Hyper-V isolation from the other workloads because they don't trust whatever's running inside that container. Well, if you don't trust it, you probably don't want it talking to the Service Fabric runtime either. Right. And so it's weird, the mix of a thing that uses the Service Fabric SDK and I don't trust, so I have to containerize, is a very small overlapping Venn diagram of workloads that are out there.
Yes, right. And in fact, that's the whole reason why I DM'd you on LinkedIn, asking your opinion on the article that I wrote. So I'm going to put it in the chat here. So
yeah, I mean, we support it. It's there for a reason, because there is that, when you look at the world, that niche is still actually large.
Yeah.
But in practical cases, we expect either untrusted, fully containerized workloads or stuff I'm getting off the shelf that just happens to come as a container to be one big set of workloads, and then things that are, don't need the benefits of containerization and can run more efficiently as processes to be kind of the other big bucket. And so we support those 2 big buckets, and we support the more rare overlap between them.
Okay, thanks.
Sorry, my Teams has quit scrolling, so it's a little hard for me to get to the next question. If somebody else can read it.
The next one is, okay. We already did Parson. So So, hey guys, good work. Is there any update on standalone reliable collections library still on the roadmap? I think it's a question mark. Oh, sorry. I think I missed one. Sorry, I think I went a little bit over. Give me the next one is from.
Is this stuff from Whit? I think I see Whit's question, so I'll tackle those. When actors are generated in a solution, you get this generated ref. Nothing else has this. What's it for? This is an attempt by the tooling to track the actor types, because we do some generation stuff with the actors that we don't do for other things. I don't think it's terribly useful, and we're working with the tooling to evaluate whether or not we need to still be doing it. It was used for this tracking reference that they also use to do some interesting debugging things in the F5 experience. But I admit that I've ripped it out of a lot of projects that I have and haven't really seen any ill effects. So we're working with the tools team to figure out exactly what that thing's for and whether or not it's still necessary today. Your other question is, I think, actually more important, the issues repo. So those of you who have been with us for a while know that we've been in this weird torn state where we had the Service Fabric issues repo, which was a repo kind of on its side that didn't have any code associated with it, where we had you open questions. And then we had repos where we actually kept the code. And that code repo started off under Azure and then moved to Microsoft. So we have two different orgs with two different sets of repos for two different purposes. And what we're finally doing is consolidating all of that. So the Microsoft Service Fabric repo with the code is kind of where we still keep the code, and when we're trying to migrate all the issues into that same place, or at least nearby, so that it doesn't feel as strange. So the old repo location is closed. If you go there, you should get redirected to the new one. Please let me know if that isn't working for some reason. We're still taking issues, right? It's just over in the new location. And this closing down the old one gives us a chance to like mark and sweep and clean everything up there and make sure that things are ported over. Regarding getting the code updated, yeah, I really wish we were more on top of that. I know that I went looking for some code related to a feature that shipped in 7.1 and couldn't find it in the public repo and was ticked the other day. So we're working on getting improvements to our release process so that when we do a release of Service Fabric, that the code gets published automatically. We had a process for doing it before, but frankly, it was very, very manual and required a lot of personal effort from people on the team in order to do. And it just wasn't sustainable in the way that it was. So there's a pause right now while we figure that out. And that's hopefully the thing that we're gonna bring back next. But we wanted to solve some of the issue and repo duplication first so that we had a consistent story there. And now we can resume publishing, hopefully, in a meaningful time frame around when we actually do releases. And it looks like we're probably going to have missed Matthew's questions here, but I'll try and answer them quickly.
I can read it, Matt. The audio, or did you already read it?
I got it. So he has a question because he's noticed that Dynamics AX and FO on-prem is actually hosted on top of Service Fabric clusters. We're working with the Dynamics team to improve some of this documentation and provide more information. I think it's fair that to say that it's a little rough right now. This was partially a gap between the two teams where the SF org has provided some generic information for people building Service Fabric clusters on-prem. And then the Dynamics team went and did that, which is great. We love to see our stuff used by our Microsoft partners, and we support them. We thought they were going to be providing a little bit more information about the management operations that Dynamics AXFO operators would be required to do on-prem and some of the concepts that were useful for them. They have some, but it appears to be that people are asking for more, and that's a fine question. And we're working to fill in that gap and make sure that these sorts of scenarios are covered. So I think we apologize for the gap currently, and we know that we're working to address it. Whit asks about, given a number of these services being spun up their own repos, is there a master list of where and how to find all of these service repos that are maintained? Yeah, that's something we need to do. I know that we had a list on the old code repo where it pointed to, for example, the ASP.NET repo where we do the integration there. I think getting that into not only a master list, but also talking about the releases and updates and roadmaps and stuff that we're doing in some consolidated way would also be useful. So that's a fair criticism, Whit, and I think we know that that's something we need to improve on. Oliver asked about, sorry, what was that?
No, I think, yeah, go ahead. The next.
Yeah, Anthony, that's unfortunately work for you, so thank you.
Reliable collections and stateful services. I think it's a second question from Oliver.
Sure.
Do active secondaries utilize memory RAM differently to primaries? Do they use disk while they are secondary to conserve memory on the nodes?
So the answer is that today the secondaries load everything into memory as well. So the memory consumption between the primaries and secondaries should be comparable in terms of the state consumption. Clearly, there's usually differences because the secondaries don't have open communication listeners. They're not actively receiving requests. So those parts you don't typically see loaded in. And so memory consumption overall is a little lower. Today, the secondaries do keep all of the state hot in memory. And so that's specifically so that when there is a failover, the secondary is ready to go. If we deferred, building indices or some of the work that we do under the hood until the failover happened, if you had a lot of data, the first thing your secondary would do when we're trying to turn it into a primary is spend a lot of time rehydrating stuff from disk. And so you'd have a greater window of time when that new primary wouldn't be able to do any work. And since SF cares deeply about, hot standbys and quick failovers, that's bad, or it's not ideal. So you will see some memory consumption differences. There's a few things we do differently, but it shouldn't be substantial. The majority of the state that you put in the collections will be kept hot in memory on the secondaries so that when a failover happens, it's ready.
Do you load both the keys and values into memory, Matt? Or do you just
today we do. Today we do. Keys are always in memory on both the primaries and secondaries. Values are always in memory unless the machine is under memory pressure, at which point we will give up the values that have been least recently used, and those will end up only on disk. So if you then touch that value if you touch that value, then that one will be a little slower to get back into memory.
Okay.
But that behavior is consistent between primaries and secondaries.
Thanks.
Okay, I think he had another question with him. Oliver, I think I read somewhere, possibly on GitHub, that some actor metadata remains in state when you delete an actor, and is it impossible to remove it? Is this true, or did I dream this?
You partially dreamed it, but it's worth talking about anyway because people have been bit by it. So there's a difference between deleting an actor and the actor being quote unquote garbage collected. So if you create an actor in Service Fabric and then don't touch it for a while, eventually we dehydrate it and put it just on disk. So on disk, you have any state associated with the actor's IDs, its name, any other sort of little metadata that we keep around, the underlying bookkeeping that we have for that actor object. So people sometimes have gotten confused between an actor that was garbage collected and an actor that was actually deleted. If an actor is garbage collected, its metadata is still there on disk. Clearly, if you just create tons and tons and tons of actors and never talk to them, that metadata will eventually fill up the disk. If you delete the actor, there's an explicit delete API, then that metadata is cleaned up and we forget about all of it. So you're remembering something and partially dreaming, and it's worth talking about because it is confusing. So thanks for bringing it up. For OS disk, ephemeral disk migration, I don't know that we will ever do in-place stuff for this sort of thing. I don't even know if the VM scale set allows switching it in place. I'd have to go look. We tend to not recommend doing stuff in place because a lot of these infrastructure operations in Azure are not reversible. So if you get midway through them and it turns out that it's causing some problem in the environment, the best we can do is pause and then figure out some way of mitigating it. So what we tend to recommend people do instead is you stand up a new scale set, you move the services over, and then you delete the old scale set. And that's our guidance for SKU changes, a lot of other VM level property changes. It's just hard to do in place and a little risky. It might work in a lot of scenarios, but it's still, for the people like me who are paranoid, it keeps me up at night thinking about doing some of this stuff in place. So we tend to recommend doing it on the side, and that'll remain the same for the ephemeral OS stuff.
I think it's been a while since Martian identified how to successfully run an SF cluster across multiple regions for redundancy. Is there any official how to about doing that in a supported manner or better?
So the short answer is that, yeah, in Azure SFRP, no, because that's not really a scenario that Azure SFRP plans to support right now. If you were to do it on, say, Azure IaaS, but a Service Fabric standalone, Service Fabric, the runtime doesn't know that the VMs that you're connecting are across regions. That said, it's still a very complicated topology to stand up. So while it is supported from the Service Fabric runtime, frankly, we don't see too many people doing it in Azure. Normally, what people do in Azure is they stand up separate clusters and forward the traffic either through something like Traffic Manager or write to some shared backing consistent store like a replicated SQL database or multi-master Cosmos DB. Those are the most common things that we see. If you're really stuck in a 0 RPO, RTO, instant automated failover scenario across regions in Azure, I would say call us up. Most people are able to get away with a backing store like geo-replicated blob storage or multi-master Cosmos.
Okay, good to know. I guess specifically on the last question, though, I guess my question was about the primary node types, and that I know for things that aren't, the primary management, spin up another VM node type, add it to the placement constraint, services increasingly migrate over to it, spin down the first one, you're good to go. But I seem to recall that there was some problem with that, of doing that with the primary node type.
It's basically the same. There's a period where for a while you're in one of two bad states. Either you have two node types marked primary, or you have the primary node type stretched across two VM scale sets. Both of those are bad for various reasons, but it's intended to be transient. We're also working on better guidance there. The current guidance is very manual and also talks a lot about, it presumes a few things about how, say, networking works. So I think we have to go update those docs in order to make that scenario a little simpler.
Is there, I guess, any monitoring tooling to show, I guess, if the system services have been properly replicated? Because I mean, on my own services, I can just take a look and go do health checks. Is there anything to do the same thing to ensure that's been properly?
Yeah, it's the same. Okay. So like normally what we see people do is one of two things. You either go for it all in once, and instead of saying node type equals A, you say node type equals B, and the services just move, and hopefully they all move fine. Or you go placement constraints, node type A or node type B, and then you slowly disable all of the original node type, and then things kind of slowly drain over one at a time.
Okay.
Again, pros and cons, one's faster, but if anything goes wrong, it's more abrupt. On the other hand, the second one is more graceful, and you might be able to catch any issue you cause or misconfiguration sooner and have it impact a slower amount, but you're in this weird torn multi-node type state for longer.
Sure.
There's no good answer today, and it's just kind of one of these things where we are working with the VM scale set team to allow more of these properties to be changed safely in place in a rolling manner that can be backed out, but that's just not how the VM model really has ever existed inside of Azure. And so it's a considerable piece of work to see if we're ever going to be able to get to that sort of thing. So in the meantime, we recommend this side-by-side thing, and you have to do this dance one way or the other.
That's fine. Thank you.
Yeah.
So Matt, just a time check. About 7 minutes left. So
that's okay. Speed run.
Hey, this is from Rich. Hey guys, great work. Thanks, Rich. Is there any update on standalone reliable collections library? Is it still on the roadmap?
Yeah, that's been paused a little bit while we figure out the relationship between things like Dapper, the replicated block store, and what we need to do in order to host some of these other environments. So we started to talk a lot last year about serverless environments and workloads where the your services are a little bit more abstract from the Service Fabric runtime. We talked about running your stateful Service Fabric services inside containers and trying to figure out how to do runtime support for that. And I think we threw a bunch of ideas up and then got a lot of feedback, which is good. On the other hand, we've realized that some of these things don't work or aren't going to work quite as well as we thought they were going to do. So we still want to provide some solution for this sort of scenario. It might end up looking like reliable collections as a service that gets exposed inside the cluster rather than as a library that you carry around with you. So you get a lot of the benefits of the collection model, but your service gets to remain kind of stateless. We're also still looking into the block store, maybe not so much as a way to replace or supplement the collections, but as a way of doing more on-prem migrations from things that they're thinking about that are talking to reliable disks today. So this is an area where we're still doing a lot of investigation. I think if you're interested or want more information, we'd love to follow up. Get your feedback. Where is SF with respect to serverless, service mesh to the hibernation? Right. So what we said on this community call a few times is that Service Fabric Mesh in its current form is unlikely to GA. What we've been doing is, first of all, learning a lot from it. So some of the things we learned about is that people wanted the application model to be more abstract and independent of the orchestrator. That's where some of the work around OHM came from. We've learned that people wanted their programming models to be more abstract and less tied to particular orchestrators. That goes for Kube too. And so that's kind of where some of the Dapper work came from. With respect to serverless, what we're trying to get to is still a very mesh-like scenario where you might have your Service Fabric cluster, but it's got either, we're going to do some things to it. There's work ongoing where kind of the first things we're focused on is what we're kind of calling encapsulation, where a lot of the resource management today, the networks, the disks, the VMs, we encapsulate it. And so you kind of go through the Service Fabric resource provider in order to do some of these things like rotate keys, change VM SKUs, scale. And that way we get to moderate and mediate a lot of those operations and do them safely on your behalf. That's one thing that we think is going to help, and it kind of moves you towards serverless. The second thing we're talking about doing is that today the system services live inside your cluster, and that means that you can't do things to your cluster like scale it to 0, because if you do, you've taken away your control plane. So we're talking about moving the system services out somewhere else, perhaps again as a service, so that you have more flexibility around the types of operations that are safe to do in your cluster, and therefore you don't have to be as nervous about accidentally screwing up the infrastructure. So you would see less infrastructure. That infrastructure would be managed more on your behalf, and you will have less of it because we're going to take some of it that's useful for the system services and move it on the side and manage it on your behalf. So that's towards serverless. It's not fully serverless, but it eliminates a lot of the biggest pain points that we've seen with people managing their clusters today. There's some also future work about like maybe we take your VMs and instead of them being VMs, they are just containers running on something like ACI. So you get the benefits of scale and speed of containers, but you're still using a Service Fabric orchestrator. These are all kind of prototypes and things that we're kicking around. I think if you're interested in this, again, a good thing to do would be to get in touch, and we can, kind of bounce ideas off and see what resonates and what makes sense. Only got a few minutes left, so I'm going to try and go ahead.
It's about monitoring for standalone clusters. Is there a good post or recommendation, a doc on the best practices for monitoring standalone clusters? And there seems to be a bunch of options in Azure. So what is
I think part of the reason there's not a good set of docs for standalone is that we don't know what monitoring you want to do. So it depends a little bit on the environment and what you want to hook it up to. Generally, everything that SF does just gets dumped into ETW. So you have something that can pick up from ETW and emit to whatever, then that's an option. As Charles mentioned earlier when we talked about Fabric Observer, there are places to plug in observability and this sort of monitoring, but we kind of want to know what the sync is before we can say too much. So if you have a on-prem cluster today and want more information here or want advice on how to do this, I would say send me. And is Deep on the call by chance? No. Send me
I can add my email.
Yeah, let us know, and we're happy to help look at what environment you have and figure out what the best guidance would be. Is there a timeline for Reliable Dictionary 3 GA? Not at this time, but I think if you do have feedback on the APIs, please let us know, and we can follow up and see when a timeline would actually be. 7.0 release notes spoke to building at ASP.NET Core 2.1. 8.0 expected the same thing. .NET 5 support. Is 8x also expected to support .NET 5? I don't think we know yet. We certainly want to be as close to the same date as possible, but there are some things we have to do in our engineering systems in order to support upstream versions of .NET or up-level versions of .NET. One of the first things we're trying to do is to get the story for .NET Standard or .NET Full Framework. Core 2.1 has to last until next year because that's when that finally goes out of support, and then 3.1 and 5. So 3.1 isn't supported yet, I don't think, not fully anyway. And in order to support 3.1, there are some things that we actually want to support 3.1 because we can get rid of some stuff that we had to do back in the 1 and 2 timeframe, where 2.1, 2.2, and 3.1 have support for stuff. Async enumerable, the preload hooks, some other stuff that we want to be able to leverage. So we're interested in getting up there as soon as possible, but I don't think I have a date for it at this time.
One thing I want to add, Matt, that is, like, I think there was we are working on revising the schedules because when it comes to November, December, towards the holiday period, we want to account for the code freeze window. So it's not set in stone. Like we will working on revising the release schedules for the year, and we will publish it soon. So
yeah, this is a good example, and Anthony, of more stuff that we need to put into the release notes and timeframes and stuff.
Yeah.
Okay, we're running out of time, so I'll try and answer a couple last questions here. What's the SF guidance for handling large numbers of writes to reliable collections? I think we would say there is actually the Event Hub processor host, but the main thing we have to figure out in each case is the latency and the performance that you're actually seeing. I would say definitely data should be going into event hubs first in most cases, and then we usually end up seeing the Service Fabric services as consumers out of Event Hub for processing, because then you can parcel it out kind of as you see necessary. But there are features that Event Hub doesn't have. There are protocols that Event Hub doesn't support. And so there are cases where you do end up talking to SF directly. And Event Hubs is just using SF under the hood to do some of the same stuff. So you're not exactly out in the woods by doing it that way. It is definitely doable. Reach fine day. And looks like we got most of the questions. Woo! All right. I was worried. We were going to be close. So thanks everyone who called in and asked questions. It was good to see you all. I hope everyone is well. Stay safe, and we'll see you for the next community call, which should be, if we do it right, on the third Thursday of next month, as per normal. So
yeah, we'll get it right next time. Yeah.
We'll try and get it right. Don't overpromise.
Yeah, I will try and
Great.
get it right. Yeah.
Thank you very much.
All right.
Thanks, Matt.
Thanks everyone.
Thanks, Matt.
Cheers. Bye-bye.
Take care.
Thank you.
Yeah.
Thank you. Bye.